What if the greatest conversation in history has already been happening all around us? And we are the only species not participating? Every morning, forests wake before we do. Birds call across the canopy. Wolves communicate across valleys. Whales exchange signals through miles of dark ocean. We hear sound. They may be exchanging information. For centuries, humanity placed itself at the center of intelligence. Language was our proof. Speech was our dominance. Complex grammar was our crown. Animals, we assumed, operated on instinct, signals, reflex, survival. But what if that assumption was the mistake? In the early 20th century, inside a quiet laboratory filled with wires, brass instruments, and experimental audio equipment, one engineer began asking a dangerous question. What if animals are not voiceless, but untranslated? His theory was simple and radical. Language is not defined by vocabulary. It is defined by structure. Patterns that repeat with intention. Sequences that carry context. Variations that change with audience and environment. If those elements exist, then communication exists. And if communication exists, then meaning exists. He began recording birds first. Not casually, but obsessively. Hours of audio. Days of observation. Weeks of isolating specific triggers. He noticed something strange. Certain calls appeared only when food was discovered. Others emerged only when a predator approached. But more interestingly, some sounds appeared only in the presence of specific birds. The patterns were too precise to ignore. He moved to wolves. Field microphones captured long-distance howls across snow-covered forests. On raw playback, they sounded chaotic. But when visualized as waveforms, structures began to appear. Clusters, intervals, recurring tonal signatures. Different wolves produced slightly altered variations of the same bass pattern. Hierarchy was embedded in frequency. Then came dolphins. Hydrophones lowered into coastal waters captured clicks and whistles layered in rapid succession. When slowed and analyzed, the signals were anything but random. They followed timing structures, almost like punctuation. One repeated whistle seemed tied to a specific dolphin, an identifier, possibly a name. The engineer believed he had enough evidence to attempt something extraordinary. He built a machine, not elegant, not advanced by modern standards, but conceptually ahead of its time. It recorded frequencies beyond human hearing, mapped tonal shifts, compared patterns across contexts, then assigned probability-based linguistic equivalence. It did not claim perfect translation, only correlation. During a small demonstration, he placed a raven in front of the device. Observers gathered quietly. He asked a simple question into a microphone. "What do you see?" The raven responded with a sequence of sharp vocalizations. The machine processed the signal. A narrow paper strip emerged. Printed words appeared. "You are loud. You break the trees." Silence filled the room. Some laughed. Some frowned. Some left. But no one forgot it. Funding followed briefly. Interest spread cautiously. Then something changed. Grants were withdrawn. Research access restricted. Institutional support evaporated without explanation. Within a year, the laboratory was closed. The machine disappeared. No patent finalized. No prototype archived. Only journals remained. In the final entry, written in hurried handwriting, the engineer left one sentence. "They are aware of us." After that, nothing. For decades, the story survived only as rumor, a scientific myth, a forgotten experiment buried under more comfortable theories. But technology continued to evolve. In the 21st century, artificial intelligence began analyzing animal communication at unprecedented scale. Millions of recordings, billions of data points, algorithms trained to detect patterns beyond human perception. And once again, structures appeared. Prairie dogs were discovered using distinct alarm calls for different predators: hawks, coyotes, humans. Parrots demonstrated contextual word usage beyond mimicry. Dolphins confirmed individualized signature whistles functioning as names. Elephants communicated through infrasonic vibrations that traveled miles underground. Whale songs evolved over time, themes spreading across oceans like cultural exchange. Scientists remain cautious. They avoid declaring it language, but they acknowledge complexity. They acknowledge syntax-like ordering. They acknowledge contextual variation, which brings us back to the lost device. What if it was not fantasy? What if it was simply early, ahead of its time, ahead of computational capability, ahead of social readiness? Because true translation would change everything. If animals can express memory, fear, preference, recognition, then they are not background life forms. They are participants. If they can describe habitat destruction, if they can recognize individual humans, if they can communicate loss, then our ethical framework shifts dramatically. Understanding creates responsibility, and responsibility disrupts systems. Food production, habitat expansion, industrial fishing, deforestation. The engineer may not have lost funding because he was wrong. He may have lost it because he was inconvenient. Today, research teams are closer than ever. Machine learning models now isolate vocal signatures with increasing precision. Real-time translation experiments are underway. Not perfect, but progressing. The barrier is thinning. And when that barrier falls completely, the question will no longer be, can animals speak? It will be, what have they been saying all along? And perhaps more unsettling, what have they been saying about us? The forest is not silent. The ocean is not empty. The savanna is not unaware. Conversations are happening constantly. Complex, structured, intentional. The lost device may never be found, but its question survives. Are we ready to hear what the natural world has been telling us? Because the moment translation becomes clear, silence will no longer protect us, and listening will no longer be optional.